Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we're going to look at polynomial regression. Now, polynomial regression is where regression gets a little bit more complex than we've seen previously. It's actually often termed as a special case of multiple linear regression. But basically, what we see in terms of a curve with polynomial regression, so we have a curve that can rise and fall. So it's more of a kind of wavy line. And the number of waves, effectively the number of rises and falls, that refers to the nomial or many nomials, so the polynomial. So we can actually define an order of how many polynomials we want to have. So that typically is a number between 2 and maybe 10, whatever you want it to be. So we're going to try to fit the curve in this way. So it's a more of a wavy kind of curve, and you'll see this is a little bit different how we work with the PAL, so you need to be paying attention as we look at this one. So here we are in HANA Studio. Now for the polynomial example, I've created a special data set to make it hopefully a little clearer. We've just got 20 customers this time. Again, we're working with income and lifetime spend. So let's just have a quick look at the data. So we can see for each customer, if we show income and then lifetime spend, we can see that the distribution is a little different. You can see it's almost a bit of a wavy line. So it's looking a little bit more like a polynomial distribution already. So what we're going to do is try to attempt to fit a curve to that using polynomial regression. So let's have a look at the code. Now the code, it's very similar to what we've already seen in many of the other regression and predictive analysis library videos. We've got one explanatory variable. In fact, with polynomial regression, it's simple polynomial regression, so to speak, in that we only ever work with one explanatory variable. So we've got income, and then we have our dependent variable, which is lifetime spend, as always. So we need to set up the same kind of tables with parameters, coefficients, for a fitted table, a significance table, etc. The name of the algorithm that we call when we use the wrapper generator is polynomial regression. So again, you can find that in the documentation if you want to see more details on it. So polynomial regression. Now there is one other important difference when we're working with polynomial regression. As I said already, we're working with a single explanatory variable. So the variable num parameter that we put in the parameter table, it actually takes on a different meaning when we're using polynomial regression. In this case, it refers to the degree of polynomial. So how many polynomials, 1, 2, 3, 4, 5, or 6. So it's not related directly to the number of explanatory variables. It relates to the degree of the polynomial that you would want to see. So we can set it for 2 for this example, and off we go and run. So let's run that code. It takes just a couple of seconds to run, and then we can look at our tables. So let's just refresh the list of tables, and we can see, as always, we've got our coefficient table. Let's have a look in there, and we've got here the coefficient, basically the equation that's going to be used when we actually start to predict. And you'll see that there's the one kind of standard coefficient, and then we have 2 additional ones. That's because we set the variable num, so the degree of polynomial, to be 2. So we're doing 2 polynomials here. That's why we get 2 factors that we can then, or coefficients that we can then add into the equation later. And again, the PMML, etc., allows us to see that. What we can also do is if we go to the views, we can look at the fitted data. So if we preview that and do a little bit of analysis, we go to ID, so we see each of the figures, show income. So we originally saw this with lifetime spend. Okay, but if we want to see how that's actually been fitted to our model, so this is basically the polynomial curve that we've got, we can replace lifetime spend with the lifetime spend fitted value, which is what we got from our algorithm. And there you see that's the polynomial curve that it's actually fitted for us. Okay, but maybe that's not quite the level I want. I mean, if we were to look at the significance table, we see that the R squared value is very low, 0.19, so not necessarily looking that useful or valid, and the F value is also pretty small at just 2. So what we might want to do instead is rerun this, but change the polynomial degree. So we can just uncomment this statement here. So to run again, and maybe set the polynomial to 3 instead of 2. So we update the variable num parameter, clear out the output tables so that we get just the results we want to see. Run it again. Okay, and then we've rerun our model there. And now if we go back to the fitted table and we refresh, we should see a slightly different curve. Now, as we've increased the number of degrees for our polynomial, we see it's actually fitted a slightly different curve. And we're to refresh the significance table. You can see that now the R squared is much better. It's 0.78, much closer to 1, and the F value has increased significantly as well. So it looks like having a 3-degree polynomial here, it makes much more sense than having just 2. And of course you may want to iterate that to maybe identify what the best polynomial degree value would be for your particular data set. So now that we've established a good model and we've built it with 3 degrees of polynomial, what we can then do is start to try and forecast that, or have the application use the equation to predict. So it's the same as we've already seen. The only difference here is the name of the algorithm to call, and it follows the standard approach. We have forecast with as a prefix, and this time it's polynomial R for polynomial regression. That's how it's actually going to apply the forecast. So again, you can find the details for that in the manual. We have the standard kind of signature. We have a single explanatory variable, as always, in our input data for the forecasting process. And again, I've created a view where we add all of the data together, the original source data plus the predicted data, just to make it easier for us to analyze and to interpret it. And I've added a couple of new rows, so 2 new observations, 21 and 22, 2 customers with the income values. So we're going to have to see now how the polynomial model actually will allow us to predict the values for the lifetime spend. So let's run that code. Off he goes and he's run. So now if we're to refresh our views, we'll get the predicted view, so we can see all of our data. We've got 2 new rows at the bottom with the income values we specified, and you can see the lifetime spend values that the polynomial regression equation has predicted for us. So if we were to analyze that, put it into context, do some more analysis, we've got income, lifetime spend, let's scatter, and now we can see we've got the data, and there's actually another couple of new values in there, if I can find them, which represent the new IDs that we've got. So there we can see that's our new data in the context of what we saw before. So that's it for polynomial regression. Please do pay attention with this one. You need to be careful because the variable number parameter has a different meaning, and that's basically something you're not going to see in the other regression algorithms. So please do pay attention with that subtle difference.